Look here, I got a list of some different compounds here. I've got some formulas and I've also got some names. And we've been working on the skill of how do we name these different compounds and how do we write formulas for these different compounds. And we've done it for two different types. We've done it for ionic compounds and we've done it for covalent compounds. Now, this is a mixture of two different types. Some of these are ionic and some of them are covalent. And we've learned that the way that we name these different types of compounds is different. So the rules that I have for ionic compounds are different than the rules for covalent compounds. And we need to be able to tell the difference. So if I look at this, so these three right here, I'm given a formula and I have to write the name. Now, the first thing I have to ask myself before I write out what the name is, I have to ask myself, is it ionic or is it covalent in order to name it? Because I can't use, if I look at this CaCl2 here, this is an ionic compound, and so I have to use the ionic naming rules for this. And if I do that, I should get calcium chloride. And if we keep going down here, CCl4 is carbon tetrachloride, and MgS is magnesium sulfide. You'll notice that in this one right here, I used tetra, I used that Greek prefix that we've been talking about, but I didn't use any Greek prefixes for this one and this one. That's because we only use Greek prefixes for the covalent compounds, and this is a covalent compound. These two right here are ionic, and with the ionic compounds, we do not use these ones. We don't use any Greek prefix in there. Notice there's two chlorides here, but I didn't put dichloride because, again, those ionic compounds don't use that. And now down here, if I'm going back the other way, if I'm given the name of the compound and I have to write what the formula is, so sulfur dioxide, again, the first thing I'm going to ask myself is this ionic or is this covalent? This is a covalent compound, so I'm going to use the rules for writing formulas for covalent compounds. So in this, again, I see this di here, so it's SO2. Lithium phosphide, this is a ionic compound, so I'm going to use the rules for naming ionic compounds. And with that, I have to balance charges. So lithium is a +1, phosphide is a -3. So I'm going to need 3 lithiums for every 1 phosphorus. So it's going to be Li3P. And then dihydrogen monoxide, I've got those Greek prefixes in there. So I know that this is covalent. So it's going to be H2. 2 hydrogens and 1 oxygen, so H2O. Now, you might be asking yourself, how can I easily tell if it's a covalent compound or an ionic compound? And the easiest way to tell, if you remember, and we talked about this not that long ago, the main difference between an ionic compound and a covalent compound has to do with whether it has a metal or not. That's really the only thing you have to ask yourself. Look at this. We look at this compound and we say, okay, does this have a metal in it? If it does have a metal, that means it's ionic. If it does not have a metal, so if I look at CCl4 here, I've got carbon, which is a nonmetal. I've got chlorine, which is also a nonmetal. There's no metals in that, so I know that it has to be covalent. That's the surefire way to figure out if the compound is either ionic or covalent. So if I come over here, let's write these down. Ionic has a metal in it. And if it is ionic, remember that for naming those, if I have to write the name, and if I notice it's ionic and I have to write the name, that we do not use prefixes. Again, the prefixes are this tetra or di or mono that we put in front of the word. We do not use prefixes in the name. So constantly students will do this. They'll mix up the rules for this, and they'll want to say for this one, they'll say calcium dichloride, which would be incorrect. And the other thing we want to remember for ionic compounds is that we need to balance charges. Need to balance charges when writing the formula. So down here, notice that when we get to this lithium phosphide here, I had to figure out what is the charge on lithium and what is the charge on phosphorus in order to write out what the formula is. And I did not have to do that process for this because in the name, they have those prefixes that tell me how many of each, but the ionic compounds do not have those Greek prefixes, and so I have to figure out what is the charge on each to figure out how many of each atom do I have in the compound. So then for the covalent, the easiest way to tell if I'm working with a covalent compound, it does not have a metal. If it does not have a metal, it's covalent. And so I have to use the rules for covalent compounds, which in naming it, we do use prefixes. So basically the rules are the rules for naming covalent stuff is the exact opposite. Up here we don't use prefixes. For covalent, we do use prefixes in the name. And we do not balance charges when writing the formula. So we have to, when I start showing you in your next homework assignment here, I'm going to give you these lists of compounds, and I'm not going to tell you which ones are ionic and which ones are covalent. You're going to have to know how to tell the difference between those and then use these rules accordingly, okay? Because thus far, that I've been giving you homework assignments where all of them are either ionic and I tell you they're ionic, or I tell you they're covalent, and then you just use those rules. But now I'm going to kind of mix it up, and I'm going to give you a mixture of different compounds, and you have to know when it's ionic, when it's covalent, and then use those rules. And also, I'm also going to give you a mixture of polyatomic ions. So not only am I going to give you different ionic and covalent compounds, I'll give you some ionic compounds that have polyatomic ions as well, and you have to remember the rules for those. So let's jump down here and do a few examples. I got a list here of, I've got some names and I've got some formulas. What I want you to do is I want you to take a second, I want you to pause the video, and I want you to write what, first of all, you have to figure out which ones are ionic and which ones are covalent and which ones have polyatomic ions. And you need to either, if it's the name, like this one, you need to write what the formula is. If it's the formula, I want you to write what the name is. So take a second, pause the video, go through and figure those out. All right, so I'm assuming that you paused the video here and you gave that a shot. So I'm going to go through and show you what you should have gotten. So we've got potassium nitride. So again, the first step, ask yourself, is it ionic or is it covalent? I notice that this has potassium, so therefore potassium is a metal. And again, if you have forgotten how to tell, which I hope you haven't, but if you've forgotten how to tell the difference between a metal and a non-metal, we come to our periodic table here. Remember that all the metals are these guys here on the left. These guys are metals as well, but we're not dealing with those type of compounds that are using the transition metals. So these guys, and we also include aluminum in there as well. So these guys and aluminum, those are our metals, so they're on the left-hand side here, because remember there's a staircase here that separates the left-hand side from the right-hand side. So we've got the metals over here, which are these two columns and aluminum. And our non-metals are all of these guys. We're going to leave carbon out of it, but we're going to, all of these guys here to the right of this staircase. Whoops. Carbon is a non-metal, but we're only dealing with these simple compounds here that use these. So non-metals over here, metals over here. And then also you should have on your periodic table these charges. So +1 for these guys, +2. And then over here, +3 for aluminum. We've got -3 for this, -2 for this, and -1 for these guys. Okay. So anyways, back to this. I noticed that it's got potassium. Potassium is on the left-hand side, which means it is a metal. So I know that since it's a metal, this is ionic. So I have to use the rules for ionic compounds. So that means I got to balance charges. Potassium is a +1 charge, and let me change this. Nitrogen is a -3 charge. So I'm going to need 3 potassiums for every 1 nitrogen. So K3N is what you should get for that one. Next one, N2O. Is this ionic or covalent? I've got nitrogen and oxygen. Those are both nonmetals, and so this is covalent. So I'm going to use the Greek prefixes in writing out the name for this. So I've got 2 nitrogens, so that's going to be dinitrogen. And then I've got 1 oxygen, so I'm going to use the mono prefix. So monoxide, dinitrogen monoxide. Next one, carbon dioxide. Ionic or covalent? It is covalent because I've got carbon and oxygen, which are both nonmetals. So to write the formula, I'm not going to balance charges here like I did here. I'm just going to look at what are the Greek prefixes. There's nothing in front of this, so it's just going to be 1 carbon. Di means 2, so there's going to be 2 oxygens, CO2. Next one, BeSO3. So this SO3 here should stick out to you. This is a polyatomic ion, and Be is a metal. It's over here on the periodic table, beryllium. And so I know this is an ionic compound, so I'm going to have to use the rules for naming ionic compounds, which means I don't use these Greek prefixes for it. I just write out what is the name of this and what is the name of this. And since it's a polyatomic ion, I don't make it end in "ide." Remember that if it's a polyatomic ion, I just write out whatever the name is. And you have to use that list of polyatomic ions that I gave you. But anyways, so we've got beryllium here. Forgot to spell beryllium for a second. Beryllium, and then SO3. If you go to your list of polyatomic ions, which I don't have up at the moment, but you'll see that SO3 is sulfate, so it's called beryllium sulfate. Next one, we've got calcium iodide. Calcium is a metal, so this is ionic. So I'm going to use the rules for that one. Calcium is +2. Iodine is -1. So I need 1 calcium and 2 iodines. So CaI2. CF4. Both are nonmetals, so this is covalent. So I've got 1 carbon. So I'm going to put carbon. Remember, we don't use the mono prefix if it's the first element. And then 4 fluorines. So 4 is tetra. And then we're going to call this fluoride. So carbon tetrafluoride for that one. Phosphorus trioxide. Both nonmetals, so it's covalent. So 1 phosphorus and 3 oxygens, PO3. SeO2. Se is selenium, and it is on the right-hand side. It's right next to bromine, and it is a nonmetal, and so is oxygen. So this is covalent. So it's just going to be selenium and then dioxide. Sodium oxide, metal, nonmetal. So this is ionic. So I have to balance the charges here to figure out what the formula is. Sodium is +1 and oxygen is -2. So it's going to be NaO2. Next one, MgNO3. This is a polyatomic ion. This is called nitrate. And so we've got a metal, and this would be considered a nonmetal. And so ionic, so it's just going to be magnesium nitrate. And again, we don't put dinitrate. Even though there's a 2 here and we have 2 nitrates, we don't say dinitrate because we don't use the prefixes for ionic compounds. Next one, lithium, and this is another polyatomic ion. This is bromate. And again, same thing as this one up here. So I've got lithium, and I've got this bromate ion. That's it. Last one, N2O4, 2 nonmetals. So I'm going to use the Greek prefixes for these. So dinitrogen. And then tetraoxide. And that is how we do those. So hopefully that is those give you some good examples for writing formulas and names. But again, just being aware of the different rules and being able to tell the differences between ionic and covalent, and you should be good to go.